You actually have multiple genes for globin, and they are related to one another, and it is possible to PCR amplify each of the different genes using sequences for primers that are common to each of those different genes. Likewise, if you want to isolate kangaroo globin and you only have human globin sequences to start with, you might be able to figure out a set of primers that could amplify kangaroo globin genes, carp globin genes. You name the possibilities, and they are there. You can then, of course, sequence the PCR amplified fragments that you get to study the evolution of genes and species. Obviously, a fish globin gene isn't going to be identical to a human or a cow or a frog gene for globin. So you can study the differences between the genes of different species and use that information to make statements or conclusions about species and gene evolution. You can also study the role and regulation of related genes in different species or in the same species. So you can use PCR amplifying genes as probes to study the regulation of actual genes in cells as they are turned on or turned off. We used to do this, by the way, with genes that we had cloned by cDNA cloning or by genomic cloning the hard way, just to give you a sense of the difference. If you know some sequence information, you can do cDNA cloning. When we did it many years ago, even today I suspect, you would be able to do cDNA cloning and get a clone that you want and sequence it perhaps within 3 to 6 months, depending on what you were looking at. Compare that to getting the same quantities, if not even more, of the gene of interest in a day. So that gives you an idea of why PCR is so widely used. It's obviously used in molecular biology laboratories for many of the reasons I showed you, and of course it's also used in forensic laboratories. Much of what you see on the CSI television programs often overstate how quickly things can be done. But one thing that can certainly be done quickly is PCR, dealing with the starting bits of hair or bits of skin or whatever that they get from a crime scene. Crime scene investigators can do PCR and then do analyses on that DNA. Those analyses usually take longer than what they tell you, but just getting the DNA is very quick.